Section 3.3 today, we are talking about division, specifically division of polynomials. So there's two ways we can talk about division with real numbers. Back in the day, we would say, hey, I can take 5 and I want to divide it by 3. And you could say, well, the answer is 5/3 and kind of leave it in fraction form. Or you could actually do the division, the long division. So if we did 5 divided by 3, let's just review how to do that. It'll be helpful with today's lesson. So the way you do long division is you're going to take the 3 into that first number and say how many times does that go in. The 3 goes into the 5 one time. Then you take this number and multiply it by the 3 and put that answer down here, and you subtract these two numbers, and that's 2. Now in this case, we add decimals and add some zeros because we want to know decimal values. And we bring down the next number, which is a 0. And then we do the whole process again. What's 3 into 20? Well, that goes in 6 times. 6 times 3 is 18, and we subtract that. We get 2, and then we bring down the next value, and so on and so forth. In this case, what we'll find is that we continue to get 6 repeating as we go on out. So we would write the answer as in one of two ways. We could write 1.6 repeating, or we also could write the answer as 1.6 with a remainder of 2. We used to do that in elementary school when you first learned how to do it. The other way that you can do it is you can write the remainder as a fraction. So you could say it's going to be 1, and then your remainder is 2, and so you do 2 over the number that you divided in, 2/3. Okay, so there's a lot of ways to write the answer. And we're going to focus on this way, writing your answer and then taking that remainder and leaving it in fraction form. So now let's look at polynomials. Say we have f of x equals x plus 3 and g of x equals x squared plus 2x minus 5. And if I ask you what's g divided by f, what we did in the in chapter 2 is we just wrote it like this. Hey, it's this guy over this guy. And that's kind of equivalent to our fraction here. But now we want to say, well, what if we actually want to divide these out? How do we perform long division in this land of polynomials? And so the answer is very similarly to this long division algorithm. We're going to go through that. So first of all, it's g divided by f. The one on top goes underneath the divisor, and the one underneath goes out front. Okay. And what you're going to do is very similarly like we did up here. We said, how many times does 3 go into this first number? We're going to do the same thing here. We're going to take just the x, the first term here, and say, how many times does that go into x squared? Or another way of saying it is, what do I multiply by x to get x squared? And the answer, if you think about it, is x. And so that answer goes up top. Then, just like we did up here, next step is we took 1 and we multiplied it by the 3 and wrote our answer down here. We're going to do the same thing. We're going to take this x and we're going to multiply it by the x plus 3. But it's times the whole quantity. So the x times the x is going to give us x squared, and then the x times the 3 is going to give us 3x. And then the next step, just like up top, let's see, different color, we subtracted those two numbers. The same thing's going to happen here. We're going to subtract these two numbers, only you're subtracting this whole polynomial. So again, we have distribution. That minus sign actually makes the x squared minus, and changes the sign on the 3x. So we get x squared minus x squared is 0. Now, if you don't get 0 here, you did something wrong. This will always be 0. The second term, however, will not necessarily be 0. Here I get 2x minus 3x is a negative 1x. Okay, and then just like up top, let's get another color here. Whoops. Up top, then we took this 0 and we brought it down. The same thing's going to happen here. We're going to take the next term of our polynomial and bring it down, and then we repeat the whole process. Okay, so again, we start here with pink. We say, what do I multiply x by to get negative x? And that answer goes up top. And then I take that negative 1 and I'm going to multiply that times this polynomial, and I'm going to get a negative x minus 3. Then I'm going to subtract the whole thing. So that is going to change both of these signs. So I get negative x plus x is 0. Again, should always happen to get 0 there. And then I've got a negative 5 plus 3 is a negative 2. Now, when you run out of things to drop down in your division problem, then what you're left with here is your remainder. And the way that we write it is we say this is going to be, there's two ways to do it. Because it's a minus 2, you can write a minus here, or you can write a plus and put the minus on the top of the fraction. It doesn't matter which way you do it, but the denominator is what we divided in, x plus 3, just like this remainder was written up here. So if you wanted to divide these out, you could just leave them in divided form, or you could say this is also equivalent to x minus 1 plus a negative 2 over x plus 3. Those are equivalent statements. Now, why is that important? We're going to see that at the end of this chapter. It's a tool that will help us find a piece of a graph. So right now we're just learning the technique, and if you can kind of hold your why until the end of the chapter, you'll see where this plays in. All right, let's do one more of these long division problems. All right, let's try this one. We're going to divide this out. So the top is the thing that goes, oh, whoops, sorry, I meant to do these the other way. This is going down here, and then this guy's going up there. There we go. Okay, so the top one goes under the divisor. Now, the thing that you want to be aware of when you're doing this long division, if you are missing any powers, you need to fill those in with zeros. It gets a little wonky if you don't. So it can be done, but it's just a lot easier to put zeros in here. So I am missing a cube, so I'm going to put a 0x cubed, and I'm missing a squared, so I'm going to put 0x squared. Then I've got a minus 3x and a plus 1. Okay, and that's going to be divided by this x squared, 3x, and a 2. The x squared, the quadratic on the bottom, is not missing any powers, so I don't need any zeros. Okay, first step. What do I multiply the first term by to get the first term? There. And the answer is an x squared. So I put that up here. Then I'm going to take that x squared and I'm going to multiply it by this whole quadratic in front. So x squared times x squared is x to the 4th. X squared times 3x is 3x cubed. And then x squared times 2 is 2x squared. Now, notice how all of the powers line up. Actually, let's go up to the previous problem. Check this out. let's look at our division. Notice that all the squareds are here, all the x's are in line here, and all the numbers are in line here. That should always happen. So that's one way to kind of keep track of things and make sure you're multiplying right. If your powers don't line up, you miss something. You multiplied wrong or you put something in the wrong order. So again, my 4s, 3s, and 2s are all on top of each other. Now I'm going to subtract. The number one error in these problems is people do not distribute the minus sign. So this minus sign is going to go through each term. It makes it a negative x to the fourth. These guys cancel. Then it's a negative 3x squared. So 0 minus 3x squared is minus 3x, or excuse me, 3x cubed. And then a negative 2. So maybe I'll write these in. This makes this a negative, this a negative, and this a negative. And so I get a negative 3x cubed and a minus 2x squared because I'm combining with zeros up top. Then I'm going to take my next term and drop it down. And I'm going to do the process again. What do I multiply by x squared to get negative 3x cubed? Well, I need a negative 3 and I need another x. And that's going to get those to match. Then I'm going to take now this negative 3x and multiply it by all three of these. There, negative 9x squared, and negative 6x. I'm going to put subtraction in front of this, which is going to change this to plus, plus, and plus. Now I combine. The first two terms cancel. If they do not, you did something wrong. A negative 2 and a positive 9 is going to be a positive 7. And a negative 3 and a positive 6 is going to be a positive 3. Bring down the next number and do it one last time. So you've got what do you multiply by x squared to get 7x squared? So in that case, all I need is a 7. And I'm going to multiply this 7 by everything. 7 by x squared, 7 by 3x, and a 7 by the 2. And I'm going to subtract, which is going to change all of these signs. So the first two cancel. That's my check that I did it right. 21, a 3 minus 21 is going to be 18, negative 18x. And 1 and a minus 14 is going to be minus 13. So I don't have any more to bring down, so that means that this is my remainder. So I'm going to come up here and I'm going to say plus negative 18x minus 13 over what I divided in. Okay, and this whole thing up here is my answer. Another method of division is called synthetic division. Synthetic division is really just kind of an algorithm. It's a shortcut of sorts, so that you don't have to go through the whole process of long division. I'm going to show you how to do this with this problem. This is the one that we did at the beginning. So we're going to just notice that the answers are the same either way you do it. The way you set it up is you take the top polynomial and you write out the coefficients without the x's. If there are any missing powers of x, you have to write 0. So if it drops from a fourth to a squared, then you have to put in a 0 for the cube spot. We'll do one like that in a minute. But for this guy, all we have to do is 1, 2, and negative 5. Then you're going to write kind of a bracket around it, and you want to save some space because we're going to write numbers in that spot underneath that. And then you're going to take your denominator, whatever that is, and set it equal to 0. And the answer that you get as your solution is going to go right here. All right, that's the setup. Now, the algorithm works like this. You take your first number and you drop it straight down. and you put the 1 there. I'm drawing arrows just so you can follow. You do not have to write the arrows. Then you're going to take a -3 and multiply it by 1, and you're going to put that answer right here. Then you're going to combine these two numbers in whatever way their signs dictate. So this is going to be a +1 minus 3. So that's going to give you a -1. Then you do the whole system again. -3 times a -1 is going to be a +3. And then I'm going to combine these two. A -5 and a +3 is going to give me a -2. All right. When you're done, when you've run all the way across your section there, the last number that you have is always your remainder. And then you build your polynomial, start working this direction. So this is your constant term, and this is the coefficient of the next, which is your x term. So I have 1x minus 1, and my remainder is 2. So remember how we write our remainder. We say plus a -2 over what we divided in, and this is what we divided in, the x plus 3. So this is my answer. And if we scroll up to the top, you'll see that that's what we got here using long division. All right, let's do another example, and let's make it a little bit more complicated. Let's go x cubed plus 3x minus 5, and we'll divide it by 2x plus 1. I'm going to throw you into fraction land here. All right, synthetic division, we're going to take this top polynomial and we're going to write out the coefficients. So the first coefficient is a 1, that's my cube. My squared term is missing, so I put a 0. You have to put a 0. If you miss it, you'll get the answer completely wrong. So that's really important. Make a note of that. Write it on your note card as you're memorizing this process. Then you're going to take the 3, and then you're going to take the minus 5. That's going to be what's inside the bracket. And then I'm going to take my denominator and set it equal to 0 and solve it. And that's the number that's going to come out front. So we are in fraction land, okay? It's all right, get used to it. Algorithm goes like this. 1 comes down. The -1/2 multiplies by the 1. Then I combine these two. 0 and a -1/2 is a -1/2. Okay, -1/2 times -1/2 is a +1/4. 3 plus 1/4, I'm getting a common denominator, and I'm going to get 13/4 when I add that up. Multiply again, -1/2 times 13/4 is -13/8. And I'm quickly running out of the ability to do that in my head, so I'm going to do this over here. -5/1 minus 13/8. I get a common denominator. That's going to be -40/8 minus 13/8. And if I add those up, that's going to be a -53/8. Okay, you also feel free to use a calculator. Please do not go into decimals on these, so keep them in fraction form. Use the fraction function on your calculator. This is going to be my remainder. This is going to be my polynomial. So the 13/4 is my constant term. The x term is going to be a -1/2, and this is going to be an x squared term. Okay, plus a -53/8 divided by what I divided the whole polynomial by, 2x plus 1. Okay, now we have one other thing to fix before we finish this problem. Fractions on top of fractions are illegal. The way that we fix those is you can multiply, when you've got a fraction on top of a fraction, you can multiply the top and the bottom by the same number. What that does is, first of all, you're multiplying by 8 over 8, which is 1. You're not changing the value at all. But when you multiply, these 8's cancel, and that gets rid of the fraction on top. So you're left with a negative 53 on top, and then this 8 distributes in, or you can leave it factored, it doesn't matter. But you'll get 16x plus 8, and then your x squared minus 1/2 x plus 13/4. And that's your final answer. Now, the next natural question is, well, why did we learn long division if we can do it this way? I'm going to tell you this problem's a little bit of a nightmare to do in long division form because of all the fractions. So why do we learn long division? The reason is because synthetic division, I'm going to write this down because this is a rule you need to remember. Synthetic division only works when you are dividing by a linear term. What that means, a line. That means it only no powers over 1. Okay, so it's got to be something x plus something. There's no x squareds, there's no x cubes. So in our second example, if we scroll up here, we were dividing by x squared plus 3x plus 2. Synthetic doesn't work here. So these problems have to be done with long division. The others can be done with synthetic. Now, if you don't want to use synthetic, that's fine. You can do everything with long division. It will take you longer, and we're going to be doing a lot of these because there's a really huge application for this going forward. So I would recommend learning how to use synthetic division, but long division always works, synthetic only sometimes works. So if you're just going to do one, you have to pick long division. All right, the last thing in this section is called, it's called the rational roots theorem. So the idea is, what if we don't want a remainder? So we want something to divide in evenly, we want our remainder to be 0. How do we know what divides in evenly? So let's take a polynomial. Let's say 3x squared plus 2x plus, let's say 6, okay? And we want to know what linear term, so again, no powers higher than 1, divides in evenly. Oh my gosh, I think I spelled that wrong. Divides, there you go, in evenly. And the rational roots theorem says, here are your options for things that could work and could divide in evenly. You take the number at the end and you say all the numbers that divide into that evenly. So what goes into 6 evenly? Plus or minus 1 goes in evenly, plus or minus 2, plus or minus 3, and plus or minus 6. Those are the ones that go in evenly. And then, so these are the pink ones. This is the last term, okay? And then you take your first term right here, and you say, what divides into that evenly? And I'd say plus or minus 1 and plus or minus 3. Those guys go on the denominator. And the rational roots theorem says that if anything's going to divide in evenly, it's going to be some combination of these numbers. So let's look at what they are. Well, plus or minus 1 over 1 is just plus or minus 1. 1 over 3, that's 1/3, so plus or minus 1/3. I could take 2 over 1, so plus or minus 2. I could take 2 over 3, which is plus or minus 2/3. Then I could take 3 over 1, and then 3 over 3. Now that reduces to 1, and we've already got 1, so that's a duplicate. Then I'm going to take 6 over 1, and 6 over 3, which reduces to 2, which we already have. So this is the list of possible roots. Now what this means is that if I divide in x minus 1, x plus 1, x minus a third, x plus a third, and so on and so forth, x plus 2, x minus 2, you get the idea. This is going to be the list of possible things that divide in evenly and give me a remainder of 0. Now, why do we care about that? We're going to see that in the next section, okay? But for now, what we're looking at is we're taking a polynomial and saying, what are my options? So now, this does not guarantee that something does divide in evenly. It just says if there's something, it will be in this list, okay? So I think a couple of your homework problems say, use the rational roots theorem to list out all the possible roots. And what they're looking for is this list right here. Okay? All right, I will see you next class period for application of some of these ideas.